All right, let's do section 10.1, page 485, number 19, which reads, tell whether the series converges or diverges, and if it converges, give its sum. So our series here is the summation from n equals 1 to infinity of e over pi to the n. Now this is where we need to be a little creative, because this is actually a geometric series. Now to see that, let's write out a few of the terms here. So the first term is going to be e over pi, and the second term is going to be e over pi times e over pi. The next term is going to be e over pi times e over pi squared. Now, if you remember, for a geometric series, we write that as a plus a times r plus a times r squared. And of course, this series extends out to infinity. So if I compare my geometric series, my general form, with what I have here, I can say that a is going to be equal to e over pi. But interestingly enough, r, that factor that I multiply every term by, is also going to be equal to e over pi. So now that we've identified this as a geometric series, we need to figure out whether or not it's going to converge. And as you recall, in order for a geometric series to converge, the absolute value of r must be less than 1. So we need to ask ourselves, is e over pi going to be less than 1? Well, those are both numbers that we know. E is about 2.7 and pi is about 3.14. And while I don't need to know exactly what that's equal to, because the denominator is bigger than the numerator, I do know that that's going to be less than 1. So I know that my series converges, which was one of the questions we were supposed to answer. And the next question is, what does it converge to? Well, I know that a geometric series converges to a over 1 minus r. So I'm going to have e over pi divided by 1 minus e over pi. And I can simplify this a little bit. And if I multiply the numerator and the denominator both by pi, then I'm going to get e over pi minus e, and that's going to be my sum.